Mr. Mac here, giving you something to do while you're on coronavirus lockdown. Today we're going to be looking at graphing form, both for quadratic functions and absolute value. Remember, a quadratic function is going to be U-shaped, so it's going to have that squared term, and then absolute value is going to look like a V-shaped object when we graph it. This is the generic form. So f of x is equal to a times the quantity x minus h squared plus k. This f of x can be interchangeable. It could be a y, it could be a g of x, h of x, it doesn't matter. A stands for your stretch factor. So if that stretch factor is positive, then your parabola is going to open up. If it's negative, then your parabola is going to open down. Also, if that stretch factor is greater than 1, then it's going to be a skinnier graph. And if it's less than 1, it's going to be wider. And so the idea there is if that number is bigger than 1, then it's going to make the graph grow faster. So if it grows faster, then it's going to go higher faster. So then that's what makes it skinnier. Whereas if it's less than 1, it's going to make it grow a little slower, so it'll be wider. Okay. Let's see, h here. That controls your left and right. So also part of your vertex. So the vertex is going to be defined by the value hk. It's also known as your locator point. So that is going to determine whether the graph goes left and right, and your k value is going to control whether it goes up and down. Now notice it's a minus k, so you're always going to put the opposite of whatever's there. So if it's negative 3, then it's going to be 3 here. And then k is just going to be whatever it is. So if it's 3, for example, then it's going to be 3 there. And then the absolute value is very similar, except it doesn't have a squared term, and it's going to have the absolute value marks around instead of the parentheses. All right, we're going to dive into some examples now. I'm going to start by having to complete the square in order to put these into graphing format. So let's say we've got f of x is equal to 2x squared plus 8x plus 5. All right. So what we're going to do is we're going to try and find a new c value. So I'm going to be subtracting 5 from both sides. And then that's going to give me f of x minus 5 is equal to 2 times x squared plus 8x. Now, in order to complete the square, this leading coefficient of the x squared term needs to be a 1. So I'm going to go ahead and factor or pull out a 2. So I'll be changing this to x squared plus 4x. So now the leading coefficient is a 1. When I complete the square, I'm trying to find a new c value. So if you remember, this is in the format ax squared plus bx plus c. So what we're trying to do is find a new c value that's going to form this perfect square, so we can change this format to graphing format. So to do that, I'm going to do b divided by 2 and then square it. So my b term is a 4, so I'm going to do 4 divided by 2 and then square it. Well, that's just 2 squared, which is equal to 4. Okay, so I'll be adding 4 there. Now when I went and did that, I have to think about what was in the front here. Since that 2 is there, then it's really 2 times 4, so I added a total of 8 to the right side. So if I'm going to keep with balancing this equation, if I add 8 to the right side, I also need to add 8 to the left side to keep the balance. Then I can go about simplifying this. Combine like terms here, and I'm going to get f of x plus 3 is equal to 2. This is a perfect square. I'm the one that wanted to do that. So that's going to change this. Remember what you did here when you did b divided by 2? B divided by 2 was 2, right? So that's what goes here. It's x plus 2 squared. All right, that's a perfect square. And then the last step would be to subtract 3 from both sides. So I'll be left with f of x is equal to 2 times x plus 2 squared minus 3. All right, so this is in graphing format. So the locator point would be a 2, our h value is negative 2, and then our k value is negative 3. All right, that's what I'm going to be working with. So f of x is equal to 2 times x plus 2 squared minus 3. And what I'm going to be doing is just graphing that. I want to use at least 4 points plus the vertex or the locator point. The vertex is going to be the hk value. So h is -2, our k value is -3. So if I come to -2, -3, that's my vertex. I know it opens up because that's a +2. So I can create a graph, an XY table. I just plugged in -2. So -2 into here makes that a 0, 0 squared. Everything goes away, I get -3. That's my vertex. All right, so let's try -1. If I plug in -1 into the original, -1 plus 2 makes 1. 1 squared is 1. 1 times 2 makes 2. 2 minus 3 is -1. So -1, -1 is a point. And if I keep going this way, I know this is the vertex. So if I just did this point and I got there, I should have another point that's exactly the same on the opposite side. So this is 1, 2, 3. So -3. If I plug in -3, -3 plus 2 makes -1. -1 squared is 1. 1 times 2 makes 2. 2 minus 3 is -1. All right, let's see. Let's try 0. Plug in 0. X for 0. 0 plus 2 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. So the point 0, 5 is on there. And then if I do -4, -4 plus 2 is -2. -2 squared is 4. 4 times 2 is 8. 8 minus 3 is also 5. So -3. So here's the sketch of the graph. All right, let's try one more. Remember, it doesn't always have to be f of x. It could be y, for example. So I'm going to change this one to y is equal to 2x squared minus 12x plus 17. And I got to change that to graphing format by completing the square. All right, so I'm going to subtract 17 from both sides. So I'll get y minus 17 is equal to 2x squared plus or minus 12x. I need to have that be a 1, so y minus 17, I'll factor out the 2. That equals 2 times x squared minus 6x. I can go ahead and leave that open because that's my new c value for completing the square. So I'm going to do b, which is -6 divided by 2. And then square it. So b is -6 divided by 2. And then I'll square it. So this gives me -3 squared. I'm going to remember that -3 when I complete the square. That gives me 9. So I'm actually adding 9 here. And then I'm going to also add, well, actually, 2 times 9 makes 18. So I'm also going to add 18 on the left. So since I added that 9 there, and it's really 2 times 9, there's a total of 18 being added to the right. So I also need to add 18 to the left. And if I go ahead and simplify this on the next step, I'm going to get y plus 1 is equal to 2 times some perfect square. I already know what goes here because I just did it. When I did b divided by 2, I got -3. So I know this is -3. And then squared. And if I expand that out, x minus 3 times x minus 3 is going to give me this trinomial. All right, one last step to do is to subtract 1 from both sides. So y ends up equaling 2 times x minus 3 squared minus 1. So that's in graphing format. That's going to let me go ahead and graph this a little easier. So y is equal to 2 times x minus 3 squared minus 1. right, my vertex is going to be the HK value. So the H value is a 3. K value is a -1. So -3, or +3 rather, 1, 2, 3, and then down 1. That's my locator point. I know this one's going to open up because it's positive, and the stretch factor is 2, so let's go ahead and start a table. If I plug in 3, I get -1. So plugging in 3, that makes it 0, so everything goes away, I get -1. And then I'll try, say, 2. 2, if I plug in, 2 minus 3 is -1. -1 squared is 1. 1 times 2 is 2. 2 minus 1 makes 1. So 2, 1. And then going the other way, 4. 4 minus 3 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. So 4, 1, 2, 3, 4, 1. I need a couple more points. So I'll try 1. 1 minus 2 is, or 1 minus 3 is -2. -2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. And then I'll do one more point up here, 5. Should be the same. 5 minus 3 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. And if you're having trouble doing that in your head, you can use scratch paper to keep yourself straight. Another thing that can happen is you might pick your values for x, and they might come out to fractions, so you can strategically pick any points you want for x so that you can get figure out or what y you're going to get, so you can see the shape of the graph. Let's see, I got to go up to 7. So 1, 2, 3, 4, 5, 6, 7, we'll call it. And once again, this is just a sketch, so it's a parabola that opens up, and the vertex is 3, -1. All right, let's try one that's an absolute value one. All right, f of x is equal to 2 times the absolute value of x minus 3 minus 1. X, y values. Let's try 0. 1, 2, 3. If I plug in 0, I'm going to get the absolute value of -3, which is 3. 3 times 2 is 6. Minus 1 is 5. If I plug in 1, I'll get 3. 2 is 1. 3 is -1. So if you plug in 3, you get 0. That goes away, you get -1. I need some points here. So 1, 3. Got 0, 5. I got 2, 1. I got 1, 2, 1. I got 3, -1. Let's try 4. If I plug in 4, I'll get 4 minus 3 is 1. Absolute value of 1 is 1. 1 times 2 is 2. 2 minus 1 is 1. So 4, 3, 4. And then 1. So notice how it's going to go the other direction. Let's try 5. 5 minus 3 is 2. Absolute value of 2 is 2. 2 times 2 is 4. 4 minus 1 makes 3. So 5, 3. I just want to go until you can see the pattern. Let's do one more. 6. 6 minus 3 is 3. Absolute value of 3 is 3. 3 times 2 is 6. 6 minus 1 is 5. So here's 6, 5. And then this one is going to be V-shaped. And that's graphing form for absolute values. All right, so hopefully you guys are doing well, staying safe, and we'll see you on the next one.